In this video, we're gonna learn how to design a saccharode pumping system using QRod software. You can download the software for free from ecometer.com. After installation, open the program from this icon here. Here is the terms of use, and you should accept it to open the program. Then comes the main program interface that includes some design parameters to be entered. Before using the software, there are some parameters need to be selected prior to commencing the design process. These parameters are pump type, whether it is a conventional unit or a Mark II unit or an air balanced unit. This is usually governed by the availability and the contracts. The second thing is the pump depth, which is usually selected according to the dynamic fluid level. The third thing is the tubing size, which is governed by the production casing in place and many other criteria that controls that tubing size. Back to the program, we can start entering data with the well name here. Then we will select the unit type, whether it is a clockwise conventional or a counterclockwise conventional, Mark II or an air balanced. We will select the counterclockwise conventional unit. We have the pump depth to enter here, and we can also change the units according to the company's system. We use feet here. The surface stroke length, we can keep the default value as it is for now, and it will be changed later. The pump size also keep the default value for now. For the tubing size, we have all available tubing sizes with the different grades to select from. We will select our tubing size here. Here it asks if your tubing is anchored or not. This is a major factor that affects the effective stroke length of the pump. In this example, we will have an anchored tubing. The rod data includes rod material, steel rod or fiberglass rod, and rod number, which indicates the taper design. You can find all possible tapered strengths here. For example, 86 means we are using 3 sizes as shown in the bottom right corner. Then we have the steel grade of the rods. According to the API classification, we will use grade E. And in the next section, we enter some other data used for calculating effective stroke length and pump efficiency, like sinker power weight. You can click on the calculator and let the program calculate the required sinker power weight according to the pump depth and size. We'll click calculate and use the calculation in the software here. The fluid specific gravity can also be calculated using the oil API and water cut. We will click the calculator here and enter the values of the API, gravity and water cut in percent and calculate, then use the calculations and the design. Then both tubing and casing head pressures are given according to the downstream system the well is flowing to. Then we have the pump volumetric efficiency, which is mainly dependent on the fluid viscosity and how much clearance between the plunger and the barrel. We can calculate it by knowing both viscosity and clearance values. Then we use calculate and use calculations as before. The value is brought back to the design. Here we have the pump intake pressure. Then click on Calculate. This is the preliminary design results. Now we can adjust our target rate to the required production from this well according to well test data. In this example, we will use the target rate as 250 barrels. You can write the target rate here or use the fixed increments. Then click Calculate again. The software redesigns the system according to the new input of target rate. Now, the main three parameters that can be modified to optimize pump design are surface stroke length, pump speed, and pump size. And as you can see here, there is an infinite number of combinations of these three parameters that give the target production rate. We can try to change each parameter and adjust the other ones to get the target production rate, which is fixed here. I've asked the software to fix the target rate and change everything else to match this production rate. After coming to a good design, you can finally look at the results, which is a rod tapered design and the top rod loading and the minimum API unit rating required for this well and the minimum motor size in terms of horsepower. We can try here to change the tubing size and use a bigger pump. Press Calculate again. This gave us the same production rate with much lower pump speed, which means less fatigue on the roads. We can review the data here and check that the top rod loading is within limits. Then we can save our work and we can export a design sheet with all the required data. Can print preview, and then you can print it out either to a PDF file or on a paper if you have a printer. And that was how to design a sucker pumping system using QRod software. Thanks for watching. Subscribe for more videos. Thank you again.